This video has a lot of postulates and theorems in it, but we're going to be talking about parallel and perpendicular lines and the theorems that go with them. So with parallel lines, we have a transitive rule. So basically, we know that if A is going to be parallel to B, and if we know that B is parallel to C, then A and C also have to be parallel. Again, just like the transitive property, it works with parallel lines. The next theorem is if in a plane two lines are perpendicular to the same line. So in this picture, M is going to be perpendicular to T and N is perpendicular to T. That means M and N have to be parallel to each other because they are perpendicular to the same transversal. Something to note here, perpendicular lines are not transitive. Perpendicular lines are not transitive. And then we also have a theorem that's kind of like the opposite that we just talked about. If we know that N is going to be perpendicular to L, and we know that L and M are both parallel, then we know that the other two lines are also going to be parallel. So M and N are also perpendicular. But you have to have that they're parallel first. You can't just state just because these are perpendicular that the others will be perpendicular. You have to have that they're also parallel. So here we have a proof. So I have that C is going to be perpendicular to B. Also given in this is that B is perpendicular to D, and we have that D is perpendicular to A. If you look at all that, basically I just redrew the picture. What I'm trying to get at though is that C would be perpendicular to A as well. So since in my given I'm only given perpendicular lines, we just talked about a theorem that if we know that two lines are perpendicular to the same line, these two lines have to be parallel. So I can say that A is going to be parallel to B. And the reason I could say that is going to be theorem 3-8, or else you could say that if two lines are perpendicular to the same line, then they're going to be parallel. So I'm going to draw that, and I know that these two lines are parallel. One thing that is very key is the symbol I'm drawing on these two lines means that they're parallel together whenever we see a point like that. And now I can actually go to my proof. C has to be perpendicular to A. And how do I know that? Well, the theorem we just went over, the perpendicular transversal theorem, states that if I know that this line is going to be perpendicular to this line, and I also know that A and B are parallel to each other, which we proved, then I can also say that these two lines are perpendicular. So three-step proof using the two theorems that we just went over in this video. And that is it for this video. So make sure you wrote down clearly the three theorems that went over in this video. Have a great day.